He's the myth. He's the legend. He's the scientist with all the answers and all the questions. It's time for another episode of Alex's Science Corner.
Oh, thank you. Thank you. No, please.
What's going on in the wide, wide world of science, my friend?
Is it expanding?
You know, we can do our own expand segment later on.
I think we should.
If you want to torture the listening audience,
we can do it
be
at
my
11
guest.
o'clock, Bobby.
Okay.
What's going on, Alex?
All right, so first up is last year I probably talked about the Juno probe, which is a probe that entered orbit around Jupiter. And since then, one of the things about the probe is it gets very, very close to the atmosphere of Jupiter. The reason is it's using a lot of instruments and measurements to try and get the interior details of Jupiter. And now, after doing a bunch of orbits and getting some information, they have finally got the first papers of that information out. And we've been learning a lot about Jupiter from that. The first thing that they've learned is that the atmosphere is about 3,000 kilometers deep before it gets to something other than gaseous atmosphere.
How many miles is that?
That's 1,800 miles.
Wow.
So that's
Wow.
how deep the atmosphere is. So that's bigger than
what's Earth's? Was that like 10?
Our
20?
atmosphere, airplanes fly about 4 to 6 miles up usually. Some high-flying airplanes will go to almost 10 miles up. Space is considered to be about 80 to 90 miles up.
Okay, so it's not that far.
No. It's in a regular car. If you could drive straight up, it would be
90
an
minutes.
hour and a half
Yeah.
drive.
Yeah,
You'd be
90
up in
minutes.
That's
space.
it? Wow.
Yeah.
Wow.
But you wouldn't be able to breathe after like 2 minutes because that's how far,
Well, you'd have to make sure you had an oxygen.
Yeah, 'cause
All right,
you'd-
we just
yeah,
we just
about
wanted to put
10,000
this in
feet.
perspective.
Yeah, 10,000 feet, you'd need an oxygen mask. 30,000 feet, you'd need start needing spacesuit. Or above 50,000 feet, you'd start needing a spacesuit. So just to put that in perspective, so the atmosphere, our Earth could fit into the atmosphere between Jupiter and the top surface of the planet's atmosphere. The other interesting things that they found is that the main body of Jupiter is made up of hydrogen and helium, but it is so dense at that point, it becomes a solid.
Yeah, because didn't they say it's one of the gas giants? Isn't?
Well,
Jupiter
it's a gas giant, but there's the pressure at that level when it becomes a surface, it's hydrogen and helium that become solid. So what we put in balloons to help them float in the air becomes so dense that stuff becomes solid. And what's even more interesting is that the surface has different densities because one of the ways they can measure is how the spacecraft speed changes as it goes over parts of Jupiter. And they found that surface has bands also. And as it goes over, the bands of Jupiter start to get denser and denser, so that the equatorial band of Jupiter is much more dense than the bands above it going towards the poles.
Does it also have something to do with how much of the two gases are combined at those points?
No, it has to do with spin.
Okay.
The Jupiter's, like the vast majority of planets, are going to be wider than they are tall, simply because when you're spinning, they kind of stretch out or bulge out at the equator. Now, for something like the Earth, it's something that you need really high-end instruments to measure. But on Jupiter, it's like about 5,000 to 7,000 kilometers of difference between the radius from the center of Jupiter to the pole versus center of Jupiter to the equator. So it's now, of course, as big as it is, we're not going to see it with the naked eye, but instruments can definitely measure that bulge. And that bulge is also causing the interior to squash out and become more dense. The other thing is that center part of Jupiter, the the surface part of Jupiter, it takes 10 hours to do a day for Jupiter, or Jupiter's day is 10 hours long. So as big as it is, it spins much faster than
that's
we
interesting.
do, which is, and the surface or the winds don't move at that speed. So there's a massive amount of turbulence that comes out from all that. So that's why you have those bands. When you look at Jupiter, you see these bands. It's because the different parts of the atmosphere are spinning at different rates.
In speeds. Okay.
Yeah. So a lot of interesting stuff coming out about Jupiter's atmosphere and how deep it really is. And Bobby wants the notes, and Brian's trying to keep himself awake.
Bobby always wants the notes.
All right, so the second story we're going to be talking about is researchers in Poland are developing an air-breathing engine for spacecraft. And that's one of those, And what it is spacecraft obviously need fuel to help them maneuver around. Even a spacecraft that is in orbit has to make minor adjustments or reposition sometimes a little bit to deal with various things. And they have to pack all that fuel onto the spacecraft. And when the spacecraft runs out of fuel, whatever happens after that, even if everything else is working, the spacecraft is kind of considered dead at that point. Well, what they're trying to do is, for spacecraft that are in low Earth orbit, they're trying to get it to refuel by collecting the few molecules of oxygen and hydrogen that are coming, or carbon that are coming, that the spacecraft would normally hit, which is not a lot. It's a very little bit. But that little bit still could be collected up and then used as fuel, so it could kind of refuel itself as it orbits. Right now, they've found that they can kind of do the collection, and they can produce thrust from that stuff as the fuel. The challenge, of course, is one of the things that happens is when those molecules hit the spacecraft, and which is one of the reasons why you sometimes have to have, apply thrust to low orbit spacecraft, is that those molecules slow the spacecraft down. Because as those molecules hit the spacecraft, they're slowing the spacecraft down. And so what they're trying to do is figure out a way to collect that material or the atmosphere without slowing it down as much. Because it's going to be slowed down. They're just trying to see if they can collect it and use it as fuel. So they've got two parts of this working. They're trying to see if they can get the third part working.
Where are they doing these kind of research?
Where?
Yeah.
This one is from a team of researchers in Poland. They're doing it for the European Space Agency, the ESA. So ESA may be the first ones to come out with that. If they can get a working prototype into orbit, they'll be the first ones probably to come out with that.
Interesting.
Okay. Any questions?
No, he answered them already.
All right. How exciting.
Isn't that?
Bobby.
I really enjoy this stuff, especially when we talk about
so do
space.
I, but all right.
Brian's disappointed for some reason. I don't know why.
This one didn't spark your
No, it didn't cause you to. Never mind.
Never mind.
No.
All right. If you have any questions about these stories or anything science related, you can call up Alex and bother him right now at 203
837
99.